Good morning. Welcome to this seminar on how to be a Simcenter Femap expert. And of course, you're not going to be an expert in this seminar of like 30 minutes, but I'm going to tell you how I did it. God, it's a loaded word. As soon as you say expert, people want to set you up for failing. But I do have plus 20 years experience using Femap almost on a daily basis of building all sorts of models, satellite models, submarine models, trucks, cars, planes, nonlinear, lots of dynamics. So I'm pretty knowledgeable on how to use Femap and keep my skill sets continually refreshing. I'm still learning on what's going on Femap. So this seminar is brought to you by Applied CAX, Computed Aided Technologies. That's where the X comes in because it goes from CAE, CAD, and CAM for machining and Teamcenter. And why we got started is that we're engineers. We do this every day. We advocate Siemens digital industry software that we can support, that we can provide, how we just say, pre and post sales support, and a follow-on, how to use the software as engineers, designers, and Teamcenter architects.
How do you train yourself? In this modern world, there's really not anybody around to handhold you or provide guidance. So many teams now are so lean in the industry, and everybody is really just hammered with work. There's not a lot of time for training. So the gig is you got to train yourself, and you got to figure out where are the tools to learn how to train. Because there's usually not somebody around in the office that's done it for lots of years, like me, 20 years simulation. So let's just jump in about what I'm going to talk about is if I was coming new to Femap, how would I spin myself up? And also, once I got over that initial hurdle, how would I keep learning? How do I keep my skill sets sharp? How do I make sure I'm doing best practices? All these little things that add up to build accurate simulation models quickly and efficiently. So that's the gig. Because if you're building models, if you're building accurate models, and if you're building them quickly and efficiently, you have a job for life. That's a guaranteed skill set. If they could talk about artificial intelligence, but the gig on AI is it's interpolating. It's scouring the databases and it's interpolating between points. Engineers extrapolate. We jump off the cliff, and especially simulation engineers. We're way out there. And that's one of the tricky parts is we have to extrapolate from a known basis and cross our fingers and hope that our predictions are right. I think it'll be a long time before AI catches up with this. And so what I'm showing here are some examples of the models that we have done over the years. And I made up a short little video. Let me bring that up. It's only a minute. You have a 14-year-old daughter, you understand about everything is boiled down to a minute. So composite antenna. This is the power of Femap. Multi-physics, solver agnostic, taking data from stars, CCM+, mapping it to the model, stress analysis. This is a lightweight inverter for an electric airplane. Classic Femap gig, door modes, PSD, everything. Machines, contact, glued connections, bolt preload, stress and fatigue. And space, lunar rover. Again, composites, titanium, bolt preload, normal modes, stress analysis, vibe, PSD. And our favorites, satellites, which really have everything involved: thermal, stress, vibe. So these are all models that have done inside by engineers at Applied CAX. These are not. Point about this is that the reason we started Applied was it's by engineers, and we provide the pre and post support for Siemens digital industry software based on our technical experience, internal. So back to the gist. Why are you here? What we hope to get out of this. How to get better. 1, 2, 3. Go to seminars. Yeah, a lot of this stuff, who knows? I mean, you may be listening and go, I don't need that. Throw that away. Get that. But hopefully my goal is that you're going to get one useful bit of information out of this. And since we do technical support for our simulation clients, it's oftentimes, if you've gotten an email from me, you know, sometimes I'll say, RTM, read the manual, or I'll point you to one of our technical seminars. And these are really technical. And there is a lot of them. And they're all relevant. If I would really welcome feedback. If you guys find one of these seminars, you say, that's really outdated, doesn't work, let me know, but I doubt it. You can pretty much learn a lot from it. And there's maybe 50 of them under an hour. So you're going to laugh. Read the manual. And sometimes people don't realize that there's all these PDFs. There's the Femap PDFs within there. If you look under program files, Siemens Femap, and there's also the Nastran PDFs. And being the type, people say, what makes a good simulation engineer? Someone that likes to read, because there's so much material. You have to read. You have to dig into it, and that's how I learned. I mean, it sounds bizarre, but I've read pretty much everything there, especially on the Femap, and it's well written, and they have all sorts of little cool examples, and they show models, and I mean that's how you keep your skill set sharp. Is that you don't always keep your nose to the grindstone. Mason is relatively new to the organization, and he's heard me say this multiple times. Slow down. Take time to learn what's going on, because if you're always rushing, it's hard to get better. And I sort of call it as this little phrase from Sir Robert Bragg that did Bragg's Law for X-ray diffraction. I have a material science background, and he was knighted for this very, very simple relationship. It's like 4 symbols for crystallography. And his comment was, never confuse hard work with hard thinking. And it's so true in simulation, is that we love to mesh. We love to muck around the geometry, mesh, and then blow through loads of constraints and get to the analysis. And really, it behooves us really to step back and think about how we're idealizing the structure and how we're applying constraints and loads. What is accuracy of the loads? Everything is summed up, and the way you get there is you read about stuff, and you read about how loads are applied. You read about how elements work and all that stuff, and it's all in the manuals there. I mean, it's a little obtuse, but it's really good stuff. So how do you get better? Build pilot models. Build stupid, itty bitty little pieces of junk. This is a classic. This is a composite overlay pressure vessel, and where you have an aluminum liner and a composite overlay that's wrapped around the shell. And you can really get pretty close with an axisymmetric model. And that's the gig, is you build simple. You just don't jump in with a million node model. Build simple and then extrapolate. So I think a lot of you guys know that, but I end up repeating it a lot for people. Tricks of the trade. I hope you guys here listening to this summer, you'll find something useful out of this. This is one of the things I saw the meshing, and boy, it's come a long, long way over the years. I won't take you back too far memory lane. Let's keep it fresh. When I build solid models, I'm always checking the Jacobian. Jacobian is it's a linear matrix. It converts the nodal coordinates. It converts it from global coordinates to normalized coordinates, -1, +1, for your isoparametric element. And it's a linear matrix operator, but it also tells you how much, gives you a measure of how hard it is to convert that element into a normalized coordinate system. Of course, we're solid elements, it's 3 dimensions. So a high number in Femap means that the Jacobian really has to work a lot. The element's highly distorted. And you guys have been working for a while. You probably know anything above a 0.9 for a tetrahedral. Nastran won't run it. It'll kick out an error message. And if you look at that element, you slow down and poke around, you're going to look at it and go, oh my God, what a piece of junk. And if you've been reading a bit, you know a little bit about isoparametric theory and how it uses Gaussian integration. And it's not using a Simpson rule for calculating the volume of an element. It's approximating it via Gaussian integration. So a perfect element is 1 by 1 by 1, be it a tetrahedral or a hex. And that way, Gaussian integration does no work, does a perfect calculation of volume, you get the best stress results. You guys, if you listened to me before, you've heard this phrase. It's like, if it looks good, it is good. So I know you guys want to see Femap at least once. So let's take a look at it. Okay. Now, this is a technical seminar. I'm not trying to, like, oh, this is the best thing that's ever happened here. Don't you want 2 of them? So you look down at my messages. Communications with a license server lost. Your license may time out. Well, interesting enough, this is a node locked license. It's not a server license. It's tied to my laptop because I travel all the time. So it pulls it out from the license file. There's no way, it's not communicating to the server. What happened is in the recent update 2306, they changed FlexLM and voila, now it automatically pings to the server, even if you have a node lock license. And it says, well, it's timeout, but that's node locked. So for now, you can ignore this message. Great, huh? But this is one thing. Most of you out there have server licenses. You're running a network client. You're pinging a server for a license. So you're never going to see this. This is unique to my install because I have a nodal lock. But I wanted to mention it. You see it. This is why this is a technical presentation. Okay. A chunk of junk. And if you go ahead and run it, let's say we do it with a standard solid element, right? And I'll set it to 0.25, like that. And you're going to get 100,000 nodes. And you can see in the lower left-hand corner. And then to show the Jacobian, you come up here, bang, bang, like you've seen that. Almost 1. Pretty pathetic. So you undo. I've been using this a fair bit now, hex mesh bodies. And it will go through, and it actually wraps around the geometry and smooths out the geometry. I'm going to use the same mesh sizing. And I'm down to 20,000 nodes on it. Quite impressive, huh? On it. And it captures the main features of all the geometry. It's not perfect, but it's really useful for a lot of geometry where you need to occupy space. You need it as part of a system model, and you want to capture it correctly. And it does a nice job. Now, you notice that the concept is that it's hexing what it can hex. And then the part that it can't hex, it goes ahead and puts in a pyramid element or a triangle or a tetrahedral element. So if you haven't been playing around with that, it's well worth your time. And it's sort of my I've stopped sort of using the geometry preparation as much and gone to the text, mesh, and bodies. So what? This little graph here in the corner, what that shows is that when I'm idealizing models down and beating down the node count, because usually for me, a good analysis means I'm rerunning the model dozens of times, it seems. It's never like one and done. It's like 1, 3, 4, 5 changes of looking at sensitivity, looking at where it's going to go. Having a big model that's really slow, that you have to carry around all these results, I really try to avoid it, especially if you're doing PSD work. So I'm always trimming down the mesh. And one of the ways I check to see how far I can trim it is I'll run a normal modes analysis in the free state. And if you're not familiar with that, when I'm talking about the free, I'm talking about no constraints. So you go here, normal modes, and I'll go into here because I'm not interested about mechanisms. Because I just want to look at, first, I'll block this out. It says, don't give me anything under 1, which are the mechanisms, right? And then run it. You can run it with no constraints. And so what I'll do is I'll run it like that, and I'll compare the normal modes. I'll compare the frequencies against the prior frequencies as I coarsen up the mesh. Because what a normal modes analysis is, you're looking at the permissible modes of deformation of a structure. And this is the beauty of a 20,000 node model. In a blink of an eye, it's done. And you go, wow, that doesn't make any sense. That seems really actual. No, percent. There we go. And okay, but so how do I compare? Well, what I'll do is that I'll make a spreadsheet and I'll export the eigenvalues from, where are we? Build pilot model. Nope. How do you get tricks to the trade? You see how I organize this, because when I'm presenting, it's, your head gets not eigenvalues. So this is exported with a little API. We'll talk about that later. So I make a spreadsheet and I compare the mode shapes under successive coarsening. So that's how I tell whether, hey, is the mesh converged? Can I go further? Can I make it coarser? Look at the eigenvalues. So that's one of the tricks. Okay. Surface meshing. This is, I guess, what I'm trying to cover is like, what are the big things that we do every day on building a model? Not everything, but what are the really big things that make Femap this mesh-centric FEA tool so popular? Ultimate mesh control. Quick, fast. One of the jokes I have is like, what's the start of a really good simulation model? A system simulation model is when you throw away the geometry and you're working just with the mesh. That's Femap. So surface meshing. Okay, I could kill this. No, I can leave it open. I mean, this is one of the things. If we have so many seminars on all aspects, it just seems, like how much do you really need? Because we've covered so much of it. Mid-surface, automatic, select all. I know I'll use 1/10 of an inch, combine mid-surfaces, you go into geometry. I'll blank the solid, and then you look at this and go, well, I got that big honking gap, right? And if you're meshing it, you want to close it up. So you go to geometry, mid-surface, extend, you pick the curves. And things that I'm showing here, we have whole big old dedicated seminars, on just things of like this details. But I wanted to give a quick highlight: geometry, surface, non-manifold add. And for the audience today, if these things strikes you, it's like, what is this guy talking about? Manifold, non-manifold? If you're going to be a simulation engineer with Femap, take some time, read the manual. There's no shortcuts. You just can't force feed. You know how it goes, like, oh, here, watch this. No, it takes time. Reading, playing around. You can't shortcut it. There's nothing magic. Like, I've seen it where they're so busy trying to get the model out, they can't look up and get a breath of fresh air. And if you see this on the toolbar, select visible. One of the coolest little things they've added. Select that. Yeah, okay, hit okay. Suck it together. And now we don't have two lines. We have one line, it's contiguous. And things like this is just super powerful. And you can see up here, general body add. And these are the solids that I've blanked. It's so useful. But if you're not familiar with working with surfaces or been exposed to it, you might not do it. But again, we have whole technical seminars, probably like 5, 6, 7 of them, just on surface modeling and solids. So, meshing toolbox. I use it all the time. So it's this gig, meshing, feature adding, which really works, geometry, washer, distance, 0.1, you can go through it, pick the curves and add some cute little washers. Like that. This is one solid continuous piece. And then you could go in geometry, let's go mesh control, size on surface, visible again, and like that, mesh, geometry, surface. Yeah, I use the visible a lot. I'll just mesh it with some plates. That. Control Q, I'll just leave on the curves. And if you're old school, you may go, wow, it's gotten a lot better at meshing. They've been improving the meshing all the time. Point to edge. I'll use this a lot too, just to scribe things a little cleaner. So, but you could there's so much goodness in here. Mesh sizing, for updating the meshing on the curves. There's so much stuff. But again, that's why we do these rather detailed seminars. This is the overview. Selector. Like my favorite tools, and what do I use all the time? Tricks of the trade. I wish I could say I figured this all out myself. It's one of the advantages of working in a team, of being in the office and just chit chatting. And this is a fellow employee, the stuff on the team, and he was watching me do a model once. And says, George, why don't you use the selector? And it's been out like a couple of years. I said, what do you mean? Oh, what? And he said, no, it's really great. You should try it. I go, well, what is it? And so here's the selector. This is not the selector, but this is these tools for like picking properties. And then visibility. Let me turn off that. There is the pressure vessel. There's this part here, property and visibility. Hide selected. I picked the wrong thing. See, this is live. Hide selected. There we go, like that. I want to turn on thickness. There we go. That looked cool. But let me show you what I use these toolbar here, selector entity. I should say the draw erase toolbar. So this is the draw erase. And what I'm going to do is select by properties and pick up here. And I use this a lot. It's just called the grow shrink. And you see that there's all sorts of options. It's sort of cool, just nuts. Here I'm growing the mesh now, like that. And of course, you could reverse it. You get the opposite, or you can turn it off. Turn it back on, blank it. So there. These two bars, you could they're quick, fast. I mean, I still use groups, but I use groups a lot less. I feel like my modeling is I can go faster using these little things to check out the model and get things done. So API. Now, I'll admit a dirty little secret. I basically know nothing on the API. Terrible. Because there's other guys on the team that are really, really good at it. And I mean, although I use it, I mean, look, we even got a course, learn the Femap API on Amazon. And if you're a client of ours and apply it and you want to know it, let us know and we'll send you the download link for this course for the API. You know, you start out, hello world, move forth, but it's the same gig as like all this stuff is start simple. And let me show you, this is one of the biggest things is you can integrate your API into a spreadsheet and you can drive the model. See PGM full, PGM empty, horizontal, remove all. So we set this up on the spreadsheet because we had to make so many different runs for this seismic analysis. Check this out. There's analysis set. And so I sort of call it like the $50,000 spreadsheet because the amount of engineering time it saved us by driving the model via API through the spreadsheet. So I think in bigger organizations, you have the luxury of saying, hey, Fred, dedicate your life to the API. I don't know life, but it takes some time. And I've always been pushed aside by those that are faster and quicker, more time dedicated. So, okay. Where's Simcenter Femap going? Is it worth the investment? Why am I here? It has done all the simulation. Look, it's a competitive marketplace. Of course, you got Abacus out there with CIE, and of course, a lot of people come from an ANSYS background. I came from an ANSYS background. I did my doctorate using ANSYS. I used to go to the ANSYS conferences. And it's a competitive marketplace. Even within Siemens, there's Simcenter 3D. And so what can I say on the Femap is that, man, there's a ton of people using it in aerospace. So you can see there's you got your logo soup of everybody that's using Femap. And that's just in aerospace, aviation, not to say railroad, naval, marine. It's really, it's everywhere. The big difference is just mesh-centric system modeling to do everything fast. One of the guys on the Femap team sent me a, let me get through this, sent me a boiled down version of the roadmap. So we fix to the trade, what's new. So, no, where did I put that? Let's do, nope, that's not it. Because that's the what new. Where's, don't you love it? I put, where's Simcenter right there? You guys probably saw it before me. Okay. 35 plus years. Wow, that's sort of scary. George Rudy was a simulation engineer for General Electric's aviation. It started, he was using Patran at the time, late 80s. Said, I can do better than this. So he started writing his own pre and post processor in the evenings at the end of the 80s. I think the first release was 89, something like that. And then Windows. And it always had undo built into it, day one. So what are they doing right now is always geometry, always changing. Pre-processing, they're pulling in meshing technology like that, hex body trick. FEA solver access, it's agnostic. It can handle the major, now the market's shrinking, the major brands of other analysis engines, post-processing, performance, API. But you guys know a lot. I mean, this is, Lowe's model detailed. Where are we going? Next release, June 2024. Well, mid thing, they're doing every 6 months. So I thought this was sort of interesting. They're integrated into Teamcenter. How it works, I don't know. Something to figure out the next few weeks. They're adding more and more robust on their nonlinear solver. And it's a true nonlinear solver, large displacement, large strain, plasticity. It's tricky. Any nonlinear stuff. I have like 20 years with LS Dyna. So nonlinear is a lot harder. So this is what I think. Hex dominant automatic meshing. That's what I was showing earlier today. Composite laminate, kinematic joints, linear. This last release, I want to say in 2023, was a lot on rotor dynamics. So it's out there. I've never used it. Never had to do rotor dynamics. So, but that was a big add-on to the Femap. So, and user experience. So I'm almost out of time. 9. Femap digital. Well, you guys know about that, so you can opt out of it. But they actually, I've talked to the developers on this, and they say, yeah, it tells them where people, how they're using the program, how much, are dedicated meshing solids or shells or beams, and what sort of solution sequences they're doing, static, normal modes, vibe. So, and this, I thought, news to me, HDF5. ACO. Well, was there an HDF1? Who knows? But they are trying to normalize the output files, I suspect. I don't know. So pre-processing or composites. There's so much in Femap. How much do I cover? I feel like I cover just a slice. Abacus, embedded Teamcenter. There you go. And I can't wait for this to be activated. One unified licensing format for the Siemens products. Wow. This will almost make me cry relief, because I think 50% of our technical support calls are licensing issue. And I think it's so frustrating for someone. You get new software, you get an update, it's like, it's going to break the license. And your IT department is takes you a week to do a thing, and you're like, oh, I'm not going to update my software. Everything is going to break. This should solve that. Should solve that, hopefully. Satellite results, roadmap, unified graphics. This was an issue in the first release of 2306. It's why I'm on. If you download recently, it'll be 2306 MP1 because they're porting over the graphics, and it's tricky. You know how it goes. Millions and millions of lines of code. So there you go. Automate connections to other Simcenter ports. Good luck with that. Actually, I mean, currently the connection from Femap to Star is awesome. I should say a Nastran deck. It really, really works well. Done it lots of times. So where are we? Okay, roadmap. Okay. What I hope, now I'll repeat what I think I talked about. Hopefully I made this clear during the discussion. Is I call it like lifetime simulation employment. How do you be assured that you always have a job? It's like, man, if your skills are sharp, it doesn't matter. People know, and your colleagues know. They always. We can't find engineers. Oh, well, maybe we can find engineers. We're hunting for another simulation engineer to join us. If you know anybody that would like to build all sorts of different models every day, you have a different simulation challenge, I think, every 2 weeks. So yes, we do have some projects that go on for months and months and months and years, but the normal rotation is like 3 weeks. And it's tough out there. There's just not talent. And I think it's really a great time to take up a career in simulation. It's the future. We're going to see more and more of it. But how do you get good? Take time to explore. Slow down. Please read the manual. You're going to get faster. This was taught to me by an outstanding engineer from Boeing that sort of wrote the book on landing gear analysis formula. And he said, you know, I'd get my work done, and at Friday afternoon, I would always take an hour or two off. He had a notebook with all his formulas, and I said, I'd work on something. I'd work on a new calculation, new formula to keep my skills sharp. And I really think this is good. I mean, if no one's going to begrudge you some time about learning something to be faster, and document your effort. I think documentation really keeps you focused. Open up a Word or spreadsheet, doesn't matter, PowerPoint, and just document what you're doing on your skill sets. Attend technical seminars. I do. I go to lots of classes too. I love classes. I've been to some classes twice. Be brave, ask questions. No one minds. In fact, I hired Mason, the guy I mentioned, the new guy heading up predictive, out of my Ellis Dyna class because he asked questions. I mean, they weren't always the most intelligent questions, but he was curious and he was engaged. And people, oh, that's a great, I know people, oh, I don't want to ask, I'll be embarrassed, but go for it. Build simple models, explore new features, share your expertise and experiences with others. I enjoyed doing this seminar. I enjoyed putting this together. Made me realize all the cool things, what's been happening, and also for me to slow down, spend more time learning. So that wraps it up. We look forward to hearing from your comments. Let us know if you like it. Feedback's good. Criticism is good. How are you going to get better? I know, like, what you like, what you didn't like, ideas for new seminars. This whole seminar and this PowerPoint will be uploaded to the Applied Web over the next week or so, depending on the work line. But that is it.